let's talk about how to multiply fractions. Multiplying fractions, if you're just dealing with two fractions, it's actually pretty easy. If I have 1/3 and I'm multiplying it by 2/5, all I do is just multiply straight across. 1 times 2 is 2. 3 times 5 is 15. So 1/3 multiplied by 2/5 is 2/15. It's as simple as that. So I'm going to give you a problem. I want you to do it and then check to see how you did. 2/3 multiplied by 1/4. So go ahead, pause it, solve it, and then click play and you can check your work. So when we multiply fractions, we just go straight across. 2 times 1 is 2. 3 times 4 is 12. Now this may be confusing because when we add fractions and when we subtract fractions, you have to have a common denominator. But that rule doesn't apply when we're multiplying fractions. So it's kind of hard to remember, but with multiplying, you just go straight across. Let's do 2 more, and then we'll change the problem a little bit. 1/5 multiplied by 5/6. Pause it and solve it, and then click play. All right, so we just go straight across. 1 times 5 is 5. 5 times 6 is 30. It is 5/30. Let's do one more. 3/10 multiplied by 2/5. Pause it and solve it. 3 times 2 is 6. 10 times 5 is 50. Now that's pretty easy, but when we start adding in a mixed number, it gets a little bit trickier. So let's say I was going to multiply 1.5 by 2/3. Now in this problem, I cannot go straight across because I have the mixed number. So what I like to do is I like to set up a model for it. I like to use the area model. So I'm going to just move this off to the side. 1.5 times 2/3. I'm going to set up my area model. And I'm going to choose to put 1.5 on the top, so I need to split it into its two parts, the whole number and the fraction. And then 2/3 only has one part, the fraction, so I don't need to split that, and I'm going to put it on the side. Now I'm going to take and multiply 1 times 2/3. Let me give myself a little bit more space to work with here. And then I'm going to multiply 1/2 times 2/3. We can start here because we already know how to multiply fractions. We'll just go straight across. 1 times 2 is 2. 2 times 3 is 6. But now what do I do with this? All whole numbers are over 1. So if it's one whole, it's just 1 over 1. If it's two wholes, then I can just put it over 1. Another way that I remember it is you just multiply the 1 times the 2, just 2. And then there would be one whole on bottom, so you can do 1 times 3, or you could just leave it as the third, as thirds. But either way, one whole multiplied by 2/3 is 2/3. Now when we multiplied them, we got 2/3 and we got 2/6. So we have to take those two parts and we have to add them together now. So I'm going to erase some of this. I need to add 2/3 and 2/6. And if you remember how to add fractions already, that's great. If you don't remember, I'll show you. We can't just add thirds and sixths because they have different size denominators, and so the pieces are different sizes. But I can set up a ratio table. 2/3, 2/6. I mean, I like to start with the smaller denominator. 3, 6, 9, 12, 2, 4, 6, 8. Because usually when you start with the smaller denominator, it has to go farther. And we can already see we have a common denominator. I have 4/6 and 2/6 get to just stay as 2/6. I don't need to find an equivalent fraction for that. Now, can I add 4/6 and 2/6? Absolutely. It is 6/6. Sorry, that got cut off. It is 6/6, which really equals 1 whole. So I could leave it as 6/6, or I could change it into 1 whole. Let's do another one of those. Let's say I'm multiplying 2 1/4 by 1/5. So the first thing I'm going to do is set up my area model. I'm going to try to draw it so I have a lot more space this time for my multiplying. And I'm going to put 2 1/4 across the top. So I'm going to split it. 2 1/4. 1/5 is going to go on the side. First, I need to multiply 2 times 1/5. We still go straight across. Any whole number, the denominator is 1. So 2 times 1 is 2. 1 times 5 is 5. Now I need to do 1/5 times 1/4. Just go straight across. 1 times 1 is 1. 4 times 5 is 20. So I'm left with 2/5 and 1/20. But I need to put those two together. I need to add them together. So let's start that right here. I'm just going to leave the original problem here. We're adding 2/5 plus 1/20. Okay, perfect. So I'm just going to move all of this, set up my ratio table. 2/5, 1/20. Now take a second and just look at the denominators. It doesn't make sense for me to continue this ratio table because this is already in 20ths, which that number is way bigger than fifths. Like 5, I would have to continue my ratio table for quite a while just to even get to 20. So I'm going to start with my 2/5 ratio table. 10, 15, 20, 25, 2, 4, 6, 8, 10. And I'm glad I started with the fifths because I have already found my common denominator. 2/5 is equivalent to 8/20. 1/20 gets to just stay as 1/20. And now I can add 8/20 plus 1/20 equals, if I don't have space, I might have to write it off to the side. 9/20. Yeah, I kind of ran out of space. But that means that our original problem of 2 1/4 multiplied by 5 equals 9/20. Now, if you solve these a different way, as long as you get the same answer, that's okay. Like if your process is just a little bit different, no big deal. Okay, I want you to solve this one. 3 3/4 multiplied by 1/3. So go ahead and pause it and solve it, and then click play when you're ready. First thing I'm going to do is set up my area model. so that I can multiply 1/3 by both 3 and 3/4. I'm going to put my 3 here, my 3/4 here, the first part and the second part, the first part, the second part, and I'm multiplying it by 1/3. So I'm going to do 3 times 1/3. The denominator on 3 is 1 whole. Multiply across, 3 times 1 is 3. 1 times 3 is 3. So this really equals 3/3, which really equals just 1 whole. That makes our math a lot easier. Now in this one, I'm doing 3/4 times 1/3. 3 times 1 is 3. 4 times 3 is 12. So this equals 3/12. And when I add them together, I just have 1 plus 3/12, which really equals 1 and 3/12. So my answer is 1 and 3/12. Now let's look at if I have two mixed numbers instead of just one. A mixed number is when you have a fraction and a whole number. So if I had something like 2 3/4 multiplied by 1 1/2, it's the exact same process, just this time when we draw our area model, we have to split both of them 2 ways. So let's see. I'm going to start by drawing my area model. Okay, so I need to put 2 3/4 across the top, so I go 2 3/4, so I'm going to split it right down there. Now on this side, I have 1 and I have 1/2, so I need to split that into the whole number 1 and the fraction 1/2. And I'm going to solve just like normal. In this box, I'm doing 1 times 2, which equals 2. In this box, I'm doing 1 times 3/4. And I don't even really need to do all the work, because anytime we multiply 1 by anything, the answer is just the other number, but I can still go through the process. A whole number is always over 1. 1 times 3 is 3. 1 times 4 is 4. So my answer is 3/4. In this box, I'm doing 1/2 times 2. So I've got another whole number. I just make the denominator 1. 1 times 2 is 2. 2 times 1 is 2. So my answer is 2/2, which really equals 1 whole. So I'm just going to change it into 1 whole. When the denominator and the numerator are the same, it's a whole. Now in this box, I'm doing 1/2 multiplied by 3/4. 1 times 3 is 3. 2 times 4 is 8. So I get 3/8. Okay, now I have to take this whole mess, if you will, and add it together. So I'm adding 2 plus 1 plus 3/4 plus 3/8. I'm just going to write that in an addition sentence for us. 2 plus 1 plus 3/4 plus 3/8. Now, we can already add part of that without doing much work. We already know what 2 plus 1 is. 2 plus 1 equals 3. So I'm just going to add that for us already. Take that step out. So now we need to add 3 plus 3/4 plus 3/8. So I'm just going to set it up here. 3. And I like to keep my whole numbers on one side, fractions on the other. 3/4, 3/8. Because when I add fractions, or mixed numbers, I add all the whole numbers, and I add the fractions separately. So I need to add 3/4 and 3/8. Well, I can't do that because they don't have a common denominator. So let's set up a quick ratio table. If you already know what the common denominator would be in the equivalent fraction, go ahead. Like, you don't have to do the ratio table. 3/4, 3/8. The ratio table is just a trick to help you. 4, 8, 12, 16, 20, 3, 6, 9, 12, 15. So I can already see my common denominator is going to be 8ths. 3/4 is equivalent to 6/8. 3/8 gets to just stay as 3/8. Now I can add these because they have the same denominator. 3/8 plus 6/8 equals 9/8. But we can't really leave it as 9/8 because that is an improper fraction. The numerator is larger than the denominator, so we need to change it into a mixed number. Well, if it's more than one whole, then I know I can take out one whole, which is 8/8, and I'm going to just change that into one whole. But if I take 8/8 out, I'm only going to have one left over. So I had one whole and 1/8. So 9/8 really equals 1 and 1/8. Now I can bring in my 3 that I added in. So I have 3, and I have 1 and 1/8. I need to put all of that together, and it will equal 4 and 1/8. So we just did a ton of math to solve what 2 3/4 multiplied by 1 1/2 equals. And our whole answer comes out to be 4 and 1/8. That was a lot of work to get to that point, but that's okay. I'm going to give you one. I want you to pause it and solve it, and then click play when you're ready. 5 1/2 times 2 and 3/10. Go ahead and start solving this problem if you think you know what to do, and then click play and we'll check it together. First step, set up your area model. I have 5 1/2, so I need to split the fraction from the whole number. Put 5 here, 1/2 here. I have 2 and 3/10. I need to just put the whole number and the fraction. Split it there. Now I can multiply. 2 times 5 equals 10. In this box, I'm doing 2 times 1/2. Now we know all whole numbers, the denominator is 1. So just go across the top. 2 times 1 is 2. 1 times 2 is 2. And in this one, we get 2 halves, which really equals 1 whole. In this box, we are doing 3/10 times 5. Again, whole numbers, the denominator is always 1. 3 times 5 is 15. 10 times 1 is 10. And at this point, we get an improper fraction. I like to just deal with it right now and take care of the improper fraction. Improper fraction means it's more than one whole. And it's more than one whole because one whole would be 10/10, and we have more than that. So I can take out one whole, which would be 10/10. And if I take 10/10 out of 15/10, then I am left with 5/10. 10/10 really equals 1 whole. So I have 1 whole and 5/10. Now in this box, I do 3/10 times 1/2, and I get 3/20. Sorry, that kind of got messy right there. I get 3/20. Now I have 10, 1, 1 and 5/10, and 3/20. So I'm just going to write out everything that I need to add together so that I can erase my area model. I have 10 that I need to add, plus 1 and 5/10, plus 3/20. Oh, I wrote a 2. I like to line up my whole numbers with the whole numbers, and then line up the fractions with the fractions. So I'm adding 10 plus 1 plus 1 5/10 plus 3/20. Well, we can simplify part of this. I could take my 10 and 1, and I could add those two together. 10 plus 1 is 11. So I've really got 11, and I've added that and that. And I could take this whole number too and just group it in with all of them. 10 plus 1 plus 1 would equal 12. Okay, now we've got 12 and 5/10 plus 3/20. We can't add these fractions yet because they don't have a common denominator. So I'll set up my ratio table. 5/10, 20, 30, 40, 10, 15, 20, 3/20. I've already got my common denominator. 10/20, 3/20. 5/10 is equivalent to 10/20. 3/20 gets to just stay as 3/20. I'm gonna just move this stuff out of the way. I'm gonna move this stuff out of the way. 10/20 plus 3/20 is 13/20. Don't forget your whole numbers. So my answer is 12 and 13/20. So when I multiply 5.5 by 2 and 3/10, I get 12 and 13/20. Good luck multiplying your fractions. If you need any help, ask me or your teacher.